guys, welcome back to another YouTube video. It's me, Winkley, and today we are delidding the Ryzen 5600G. Yes, that CPU that no one has touched yet. I am here to claim first place in delidding it, and we shall begin right now, right here. Here we go, look at that. Shiny as die. Brand new from the factory, straight out of the box. You're gonna see it like that. But before we go all retard and start delidding it, we gotta start actually protecting it with a little bit of tape. So any kind of masking tape will do. Let's run the tape over the top here. It's both sides, like so. And then another on the other side. Here, like so. Now comes the tricky part. Take your Ryzen 5000. Only the 5000G series right now I can actually vouch for delidding. I don't know if any of the others will work properly, but we will have to see. So take that and then put it in the vise like this, sideways on to the vise, and you want to just clip the PCB on one side and then start reeling it in on a, it has to be a decent vise, right? So just make sure you hold it down with your hand so it doesn't pop out and kill itself, right? And then just start pushing. Just be gentle, you'll hear a little bit of a creak. You'll see that the IHS is actually moved to one side. Now, be very careful here not to clip the PCB when you're going back the other way, as I have done that, but it hasn't killed my CPU, luckily enough. So just get very gentle, please. Very gentle. Back it up the other way, just like that. And then reverse, once again. Do this very slowly. This will be perfect. Any way you do this unevenly, it will kill the CPU. I have done that in the past, and well, I haven't actually killed the CPU by this device method dealing, as a matter of fact, which is, well, quite fortunate. Let's see. Now, I'll get back down there, just a little bit more. And you see, every pass we shear the solder more and more, so that eventually, on one of these passes, not sure which one yet, it will actually let us fully delid that. Now I went a little bit too low on the PCB on one of the sides, so I'm just gonna move it down a bit. Give another rotation. Another pass. I think this is probably the 5th or 6th one. Very important that you watch the height of the PCB, that it does not get clipped by the vise. If you see it might get clipped by the vise, just move it up or down a little bit so it doesn't. I'm getting called on Facebook to play Rust, but nothing's more important than cutting the vise. Okay, let's get this delid done, boys and girls and ladies and gentlemen. Nearly done. I can see this does take quite a lot of patience. Quite a few passes too. Very careful here. And there is way more than this one method to break the CPU here. There's thousands of pins. Very working PCB. And of course, it's line. The shearing will just completely kill itself, which is not something you want. Now you can take this up another direction and try to push this back and forth, making sure only you go sideways when you can on particular sides here. Yeah. You will eventually have to go the other way, but we've already loosened up here. And this should be it. There we go. That's a crack open. We've got our delidded Ryzen 5600. This thing will actually focus. That is the 5600G, completely delidded. Yes, that is right. The Cezanne die is finally delidded, and that is a monolithic chip, which is great for us delidders because it is easier to delid than other Ryzens. You have a look at that solder here. It's quite well made, but it is also very soft, so take what you will. AMD's done a good job, and hopefully so have I here. Just give you a picture of that die shot right there. I'll give it a bit of a close up if I can get this thing to focus. Doesn't want to focus, but hey, you get the idea. That's Winkley coming in hot. Over and out. Now all we need to do is sand off the solder there, and then I need to sand down the top of the AMD socket because the plastic is too high for it to run DELIDs. Now there's that, and there's that. Lid right there. I'm gonna run out of battery on my camera, so I have to end it here. Alright, leave a sub, drop a like, or drop your CPU on the floor, mate. And yeah, I hope you have a good one. On to the next part, which is actually scraping off the solder of the CPU. Recommend using a really sharp razor for this, and preferably one that doesn't have any scratches or dirt on it, but I'll probably make sure what I have. So just to begin, now just kind of attack it without digging into the silicon itself. So in a very shallow angle, you come in making sure the blade is in the middle, and you're not catching onto anything. It's fairly hard to do this correctly. It's a little bit challenging to do with the edge of a table. Give that another shot. It's already gone through. I'm going to cut it too hard. I'll lightly scrape the edge here. Sound this. Some massive chunks of indium will come off. Very gentle. Last thing you want is to scrape an entire edge off with a knife. It'll be extremely counterproductive. And it's important that, unlike me, you get a bit of lighting on this. As far as I know, it's actually still quiet a bit. Anything gold or anything like that is just going to show up. It's quite a bit of solder, so you don't want to attack it directly, you want to attack it from behind. You come over here and scrape up towards it, and then, once again indirectly, cut it off from the side, so you don't touch any of the corners. Very important to not scrape off any of the corners of the silicon, otherwise you will destroy the CPU very easily. You don't want to do that either, because it's just going to bend the things. Bend this one a little bit by accident. It's not too significant. Very easy to bend back. And yeah, nothing too crazy. Alright. If you're uncomfortable with doing this, you can probably just go straight sanding, but you want to get the mirror perfect finish before you even start sanding, so you can get, well, a perfectly flat surface. That's not always easy to do. We're attacking the CPU. That isn't clean. I want to go over the edge. You never want to go over the edge. You can go over the corners a little bit, that's alright. You chip a tiny bit of the corner die off, it's not going to do anything. Because the corners aren't, well, they're not really responsible for anything in the CPU as much as the edges are. The main processing units are all on the sides and around the center area, rarely along the corners. And that's what I'd call clean enough. So enough for me to start lapping down the die. And that's going to be the next step of this process. That's probably just on the edge a little bit more. Curl it up, cut it off. And yeah, this is very simple to do. You can go a little bit at a time. I didn't rush this a tiny bit. But the idea is this is all indium solder, so it's much softer than the actual silicon itself. So it's perfectly safe to run over this with a knife. As a rule, just yeah, don't apply any pressure when doing this. You will destroy the CPU very easily if you apply pressure. And then scrape over it very gently, no pressure at all. And you should just pull all that solder off. And then the blade's a little bit blunt here and got some sharp edges and aren't really that healthy. But still, it's done a pretty bloody nice job. Look at that. Nice and flat. All I need to do is apply some fingernail polish on the edges here, 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 and here where the capacitors are and where the contact points are. And that will insulate it from liquid metal once I apply that. And yeah, that's looking pretty fly. See you in the next part. Okay guys, here we are on part 3 of the process. We are going to remove the socket cover from the socket of AM4, and then if you have a Foxconn socket, you need to sand down the top part. See how this is raised? This top part right here needs to be sanded down until it is lower than the CPU die. And it's sitting in the AM4 pin array, which is quite cool. With the LED system here, basically this thing pushes the CPU that way. And to remove this, very simple. Get a pair of tweezers, put a little bit of pressure on this top corner, and then just push the tweezers this way in the holes, 1, 2, and 3. And then you lever this top area out. There's a few holes over here and here, and down here, and then just lift the whole cover off from this corner like that. You don't want to break this, is very fragile. So here we are. You want to put your fingers, or your fingernails, into the little socket where the lever goes, and then holding it down. The other hand on sandpaper, just run it across. You can make a fold in the sandpaper so it's rougher in one place, and then run the socket cover over that fold, and I'll basically sand it down quicker. Because as any woodworker would tell you, you sand sandpaper, that part of the sandpaper is going to sand a piece harder than any other place. So it's uneven there. And you want that to speed up the process. You could use a file, but I'm not fully confident in that. Don't recommend wet sanding this yet because it will take too long. But yeah, you have a vacuum cleaner handy because these particles are very toxic. They probably are fiberglass at some time. Faraday, this is glass reinforced photopolymer. That's why it's so temperature stable. Well, it's designed to be that way anyway. So yeah, just careful not to break off the 3 little tabs at the front. They break quite easily, but you can always super glue them back into place. And yeah, the full socket cover is just a very fragile deal from top to top. It's to be expected. I believe this is ABS or nylon reinforced with glass fiber, but I think it's probably ABS. Nylon would be too expensive. So sand it down really hard until the lettering starts disappearing. See there. And it needs to go down quite a little bit more until the CPU actually rests lower than the socket cover. There you go. I'm talk crap about my fingernails, but I need them for IT. It's just one of those things in the trade. Hang here. So there we go. Fill out nicely. I'll grab one of our Ryzens here. 5600, DELID. Hopefully without knocking off anything. Let's grab that and check if the die height is alright. Of course, going to line up the arrow to the bottom of the socket. So then, let's see if we've done it correctly. That is quite close. It might even be level with the socket. No cigar. Not yet. But very close. Check that out with our session now, that'll be handy. Okay. Back to sanding. You don't want to sand the CPU with anything too rough because you'll destroy the indium layer. And you kind of need that for good liquid metal adhesion. We sanded this actually level with the CPU. We can actually just open the lever here, or if you've accidentally knocked out the lever, just put it back in. It's very, very easy. Be very careful when putting this back. Line it up on the side. It goes in like that on the sides. And then on the opposite side, they also go in like that. And they clip out on the back of that. So you'll hear it snap in. Make sure to give even-ish pressure because it does not like uneven pressure. And as you can see, the rail is already kind of snapped up on the side just a bit. And yeah, it's not ideal, but in the long run, it's not really a problem. As I said, sockets are incredibly fragile, these ones. And this is now kind of ready to go in. The last step is, of course, the sand. The top of the IHS interface, flat, is the die, of course, so you need some very fine sandpaper in order for the liquid metal to not get wrecked. This is 1500 grit. I'm just going to run this on top of that. Now ensure that when you're sanding the CPU that it is actually on a very flat surface, so I prefer to use a glass table or workbench that I got here. And then if you still have one of these kind of Ryzen tray holders, and that's something heavy, place it on top so it's more even, right? And then you can hold the sandpaper down with your hand on the other side, but I'm just going to go hold this down flat. Try to go in one direction. Lighten and then go again, lighten and then go again, and go again. Because if you do the same force both ways, it will really cancel out any kind of lapping you do by raising curved surfaces on all sides. So yeah, just do it in one direction like that until the indium is actually flattened enough that you can use it to interface well with a cooler. Otherwise, you're not going to do too great. And also be very careful not to sand down any of the ICs on the chip, because there are actually quite a few of them. You can see it's looking a lot better. Just a layer of the solder coming out right there. Okay, see you in a sec. I'm going to take back what I just said. I'm going to sand it like that, the diagonal to the sandpaper, so it doesn't look razor rich. And also that makes it that the contact area is longer in size. Therefore going to be smoother in the long run. Here we go. So rub all this indium off of the nice surface. And yeah, you can run this finger over the bottom of the CPU, just be very gentle. You might bend any of the pins. The pins are quite sturdy, especially when you're touching a lot of them. That's nearly done. You see very shiny dye. Need a little bit more pressure on the top side. Yeah, just trying to make this even as possible. Don't rush this, don't push too hard, all the sandpaper will fold on this. We'll see how I do. I'll leave my hand holding down the sandpaper while I'm doing it. So now that it's level with the IHS kind of with the water cooler, you can now put it back in the socket, just like so. As you would any AM4, hold it down because the socket's probably mounted by now, and then lock it into place. Make sure you got this aligned properly. Then run some nail polish along all the capacitors, and you can be free to liquid metal, or just run thermal paste. I don't recommend thermal paste though; it's pretty bad. Temperatures are terrible. Go. As you can see, grab a bit of nail polish, run it over the top here. Doesn't want to slather any on the die, but of course this is just removable with alcohol. And yeah, you can use the old silicone from the IHS to act as a barrier to the liquid metal. There's any of the runaway nail polish as well. So yeah, oh, no, wrong die there. You can just clean that right up. Like that. I like to make it look nice and even. And just run that around the edges there. So it looks like a straight line. Oh yeah. Okay, let's get back to it. Now it's time for the liquid metal. Excuse my dirty fingernails, but it's just the way it is sometimes. Be very careful with this stuff. You want to squeeze it on, preferably without a nozzle so it doesn't splurt everywhere. And just carefully ease out a little bit of a dot. There we go. Just going to paint that out. One of these have actually run out of swabs that they original give you. Thermal Grizzly, shout out to them. I usually use Cool Laboratory, but one of my friends recommended me try this once, and I can say that I'm decently happy with it, although I will say that it does have a tendency to want to run away from the applied area. There we go. Nothing fancy. Nothing too neat or tidy. But yeah, very utilitarian application of liquid metal. Just gonna spread it out here so that for future use on maybe Intel or DELID Ryzen, this would help. Okay, there you go. That is LM'd. And we take this to the hot air station over here. Rest this on the side, making sure it's not touching anything. There we go. Then turn the hot air gun up to about 100 and something degrees and start heating at the liquid metal. You can see it doesn't really look like it's doing anything, but it is actually doing something. So just give that a few minutes. 30 seconds or so on that will kind of just help it adhere to the nickel plating on this copper block. This is a Thermalright cooler, and this particular model here actually is a perfect fit for the motherboard, as it completely excludes the top of the socket, so I've actually just lapped the top of the socket for no, well, precise reason. Anyhow, let's get this done. That's finished. Then, just putting that over there. As you can see, I've applied a liberal amount of nail polish, there's never enough, and clean it up with, well, my fingernails, by running it over the edges a little bit, because some of it does make its way onto the die quite often, you'll find, and yeah, cleaning up that is not too hard. Let's give this a droplet. Should be nearly more than enough. A little bit more would help, yeah. There you go. Let's try that for now. I'll leave the tube aside, and just in case I need any more, I'll have some. So rub it on. If you've done a decent job, then there should still be some indium left on the die, and it should adhere very well to the indium alloy, which is a liquid metal, the gallon stand. And there we go. I find that the AMD dies like to adhere better to the liquid metal for some reason. The Intel ones I found don't do that great after you lap them. They are alright from the factory though. So as you can see, there's some that's spilling to the edge, falling off to the side. No matter. The importance of that is, well, pretty nullified. Let's spin it up a little bit to make sure none of it gets the cotton fibers stuck onto the CPU. And yeah, there we go. And that's it. Working it in a little bit more. But of course, since it's cold, it's not going to adhere very well. You want to heat it up a bit for that to happen properly. So I use the other end and clean up the mess you've made. And leave a bit of a silvery discoloration around the place, but no matter. And yeah, make sure you have enough, because it does need to interface with the actual cooler itself. You want to have enough liquid metal for there to be good contact. If there's not enough to fill in the voids, well, your thermals are going to suffer quite a bit. I have to put a little bit of a dab extra so you get a bit of a dome of liquid metal, just a very small one. You can see, yeah, some of it's like not welding properly to the die. You can see that the places where it doesn't want to alloy, you'll see like little void dots on the surface. And yeah, there you go. Just gonna rub that out a little bit more. Get it all in there. Yeah, liquid metal is just finicky like that. So now, if we simply take this, put it over here, and then run the heater again. That should fix up any of that voiding in some way. Just about 100 degrees for a few seconds, that's all it needs. And then, putting it out should be a lot easier. So the surface tension actually likes to pull itself away from us. That is, yeah, that's the way that thermal grizzly tends to behave. I don't know exactly why that's the case. I think it's better to just heat it up and leave it there. So you did too much work on it and you get more of these little voids when it's not adhered properly. So there we go. Just heat on that, alloy the indium together. That's
this on for about 5-6 seconds. Don't want this to run too long. Ryzen is very temperature sensitive. Then, simply, take the cooler, mount it on the correct side, and put it on. Do not put too much liquid metal into the cooler because that is not exactly going to be good when you put it on. It's going to be very difficult to put on without spilling any of it if you do that. Now let's get the screwdriver. Try to aim the camera while doing this. I don't use a tripod. But since now I have image stabilization on my phone, you guys can stop complaining about it. Okay, so 10 off half at a time. Just enough here. It stabilizes. I will leave the model of this cooler in the description. There's a very specific thermal writer. A longer driver to finish this off. And yeah, mounting pressure is quite good. And we shall see if this one's worked. Be back in a sec.
Alright, so I've gone ahead and chucked on a water cooler instead of the air cooler because the air cooler was initially, well, quite disappointing. The temperatures were shooting up to about 70 odd degrees, but that was acceptable. However, the chip is just bad. This LM chip, despite all the work I've gone into it, on a Pro 4 B550M motherboard by ASRock. Good staging, good filtering. That's a 6-stage for the core, and then another 7-stage filtering. But all we can get out of this is 4.475 gigahertz, and it's so bad. It's running only at 60 degrees, and it needs 1.3 volts to hold. It is literally degradation voltage, and it still will not do. Over 4.475, it is just a bad chip. Quite unfortunate for all that effort. But actually, it's a little bit lower than I was talking about. Let's be honest here. I mean, all in all, it's still worth it. It's about 75 megahertz above boost or core. And this is an all-core full hold, so only 60 degrees. That's pretty damn good. And I do have a second unit over here that is also delidded, but this one is only running off thermal paste. Despite that, and only using the Chinesium GD900, this is running at 4.625 gigahertz. The same CPU in here. This is just a better chip. And the power filtering on this is literally like non-existent. This is like, what, 5 stages maximum? Except this has 8 filter caps instead of 7. So the difference, negligible. The board's probably worse. And the fact that I had to actually manually put heatsinks onto this doesn't really give it too much extra, but definitely I'm gonna say I want to swap this into here and this into here, so we can actually make some sense of things. Because this is A520, this is B550. I expected this to clock to at least like 4.6 or something close to that, but this is just a terrible chip. Ironically, so we got a little test bench set up here, and also I can find where that cooler went. This cooler over here, which I was using initially. As you can see, liquid metal still applied. I'm going to chuck this onto the crap chip and put the crap chip into here, because the crap chip doesn't care about temperature, it cares about voltage. This chip doesn't care about temperature and doesn't care about voltage, ironically. This is only running like 1.24 volts. 1.24 to 2.5? That's well below the degradation limit, which is about 1.26 or 7. So that theoretically, I might be able to even get up to 4.7 gigahertz. So that's a little bit of a project for another minute an hour. We'll see how that goes, huh? Lads, here we go. This is the final episode. We finally got the 5600G delidded, running on liquid metal, and this is currently pulling only 52 degrees. Running OCCT on small on SSE. Now let's see how we go with small AVX2. I don't expect this to go over 60, honestly, but this is absolutely insane temperature we're looking at. Let's see. Let's go. Woo. Passing, no problems. So the temperature is 54 degrees. 54 degrees. Oh my god. Look at this thing, dude. It's absolutely insane. And it's only doing like 1.2 something? Let's see, GPU Z, CPU Z here. What's the total voltage here? And this is pretty massive. 1.27 or 2.6, probably 2.6 something volts here, 2.65-ish. Sensor's not too accurate, but thing is, we are pulling 4.6 gigahertz nearly on the regular, and well, this is running kind of PBO-ish, but that is very, very stable. Going into that, we are running very nice. This is on A520, amazingly, and yeah, the voltages are they're good. And I don't know how, but it's working pretty well. It's stably holding, at least like 99% of the time, above 4.6 gigahertz, and by God, the temperatures are amazing. I just got the drivers installed just then. Let's see here. Yep, still pulling strong. Look at that. I also noticed a strange issue with Intel Wi-Fi on B550 and A520. They don't seem to work. Like, it will work and then it won't. And this here is a USB stick Wi-Fi. I get a device manager. I can't even see the Intel Wi-Fi at all. It's just not there. Look at that. It's disappeared. And as you can clearly see, it's plugged right into there. And yeah, it's completely not functional. No idea why. Last time I plugged it up into the CPU side, PCIe, and it just blue screen. But yeah, these are our results, and they are really, really cracker. I'm gonna try buy a Maxon motherboard from China, one of those B550M iCrafts, because they have insane amounts of stages and filtering. And we might be able to see some really cool overclocks with even just a 5600G, maybe something like, I don't know, up to 4.7 gigahertz on that kind of thing. Yeah, Ryzen is incredibly sensitive to filtering and staging, and if anything, that B550M Pro 4 is a lesson to go by. Yeah, it's pretty bad. But, delidded Ryzen right here, look at that, boys. Girls, of course, 55.75 degrees on the entire thing. Just the dual radiator. And that's running 4.6 gigahertz over 6 cores, 5600G, hyper-threading off, the usual yada yada, that kind of thing. Vega, incredibly cool. I can probably pull nearly 2100 megahertz on that. No problems, dead stable. But I'll have to do some testing, of course. VRM MOSFETs, I've got some custom crappy heatsinks on those. They pull along pretty alright, they're not overheating or dying, so it's pretty amazing. Yeah, that's it. That's our little overclock there. I'll probably play some Warzone later on and see how it looks.